We have the electromagnetic spectrum, which shows the total range of all wavelengths of light. So we've done a little bit about X-rays, gamma rays, infrared heat, those things that we practiced a little bit at the beginning of the unit. Now we're going to dive into them a little bit deeper. So the electromagnetic spectrum is arranged according to wavelength. Each different type of light has a different wavelength than the one to the left or right of it. Some are very, very tiny, while others are so large that they can travel over the Empire State Building. Basically, we can only see visible light, and visible light would be the colors: red, orange, yellow, green, blue, indigo, and violet. Black being the absorption of all colors of light, and white being the reflection of all colors of light. Each wave on the electromagnetic spectrum has a different amount of energy than the one left or right of it. We have some waves that are very small, they have a small wavelength, and they are very powerful. They can kill every living cell they come in contact with. The most powerful wave that we have is the gamma wave. This gamma radiation, as you may have heard it, that is what is used to treat cancer. We bombard the cells with gamma radiation, and then the living tissue is killed, and hopefully all the cancer cells are killed along with it. Then on the other end, we have waves that are very long. They have a big wavelength. These waves have very low energy. Those are our radio waves. So radio waves would have the least amount of energy, while gamma radiation would have the most energy, and they're the most powerful waves at that end of the spectrum. We have the electromagnetic spectrum, which shows all the different types of light in a really easy to read diagram. So we start off on one side where the wavelength of the wave is really large. And then we get to the other side where the waves start to get really teeny tiny. I know my drawing's not the best, but you get the idea. On the left side, there are really large waves, and on the right side, there are really small, tiny little wavelengths of light. Now, smack dab in the middle of the electromagnetic spectrum, this small little part in here, that's the only part that we can actually see. We call this part visible light. So what we can see is red, orange, yellow, green, blue, indigo, and violet. Those are the colors of the rainbow that we can actually see. Everything else is invisible to our eyes, but other animals can see things like ultraviolet light, they can see infrared heat radiation, and those are adaptations for those animals, so this way they could survive. All right, I'm going to go down to the right side of the electromagnetic spectrum, and I'm going to go just a little bit past violet. We have this next wave that is called ultraviolet. And ultraviolet light, some uses that we have suntan, sunburn, and if you get overexposure, you can get skin cancer. So that's pretty harmful for you. A little bit more to the right, smaller waves with a little more energy. We have now what are called X-rays. And you know what X-rays are used for. They're used to see deep inside of tissue. They look for very dense material and they can reflect back. And what we do is we use this to see bone. Your dentists use it to see cavities in your teeth where they can't look. So it's a very useful type of tool that we have, this X-ray machine. And lastly, the highest, most energy wave, we have what are called gamma, G-A-M-M-A, gamma rays. So these gamma rays are so powerful that they can actually kill cells. We use gamma radiation for cancer treatment. They will actually point the gamma radiation at the tissue that has the cancer in it in hopes to kill all the different types of tissues that are there that are cancer causing. So this way the cancer doesn't spread to the rest of your body. So as we move towards the right here, we are increasing energy. we are increasing speed, we are decreasing wavelength. The waves start to get smaller. Now, if we go to the left of the electromagnetic spectrum, just right off of here next to red, we have what is called infrared, one word. And that means below red. And we use infrared. Infrared is heat. And I showed you pictures of a McDonald's with a heat lamp, and I showed you the demonstration of the heat lamp in class. That heat lamp gives off infrared heat energy. So it gives off light that feels warm. It made our radiometer move. So when we talk about heat radiation, that's actually what you're feeling. All right, so now as we go further to the left, we have even larger waves with a little bit less energy. The next one that we have is what is called a microwave. The microwave is used for a variety of different things. The one that you know is for cooking. Yes, we did not have a microwave when I was your age. We had to wait a half an hour for our burritos to come out of the toaster oven. No few seconds waiting, but a long time. So it's used for cooking. It's also used for communication. So it sends signals up into space. It's used for our cell phone signals. It's used for radar. That's pretty much what we use microwaves for. And then finally back here at the very end, the biggest and the longest one that we have are what is called a radio wave. Radio waves are responsible for our TV and our radio signals. So when a television company such as NBC, ABC, Fox, any of those, they're sending a light signal from their place in New York City. A lot of them were on top of the Empire State Building. And then what happens is that light signal goes out into the airwaves, and then you pick it up as a receiver at your house. So now a lot of you may have satellite TV. The satellite TV comes through the same way. The satellite signal gets sent up to the sky and then comes back down to you via a radio wave. So now if we went to the right where we increased energy and we increased speed, now as we go to the left, now we're going to have less energy and we're going to have a slower speed. And our wavelength now, as you can see, gets a little bit longer.